In this episode, we are going to make Windows command line networking tools feel much less intimidating by connecting each one to a very basic support question. Many beginners see the command line and think it is only for advanced technicians, but that is not the best way to look at it. These tools are useful because they strip a network problem down to simple facts. Can this computer identify itself correctly? Does it have an address? Can it reach something nearby? Can it reach something far away? Can it turn a name into an address? Once you learn to use the command line to answer those plain questions, networking becomes much less about guesswork and much more about confirming what is working before you chase the wrong problem across the whole system. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A good technician does not begin with a huge theory about what must be broken. A good technician starts small and asks what layer of the path is healthy and what layer is not. That is why command line networking tools are so helpful for beginners. They give fast, direct answers about identity, addressing, name resolution, connection paths, and active communication. Instead of saying the internet is down or the server is unreachable in a vague way, you can begin narrowing the problem one step at a time. Is the computer connected to a network at all? Does it know its own network information? Can it reach the local router? Can it reach something by address, but not by name? Can it reach the destination, but with delays along the path? Each question makes the next step clearer, and that is what keeps troubleshooting calm and logical. One of the first things a technician often needs to know is how the computer sees itself on the network. A command like hostname helps with that because it shows the name the machine believes it has. That matters more than many beginners expect. A wrong device name can create confusion in shared environments, remote support situations, and places where many systems need to be identified clearly. Another very important tool at this stage is IP protocol configuration, because it shows the network information the computer is currently using. This includes the Internet Protocol (IP) address that identifies the system on the network, along with other details that help explain whether the machine is set up to communicate normally. If you do not know the machine's name and current addressing information, you are already troubleshooting in the dark, because you are trying to fix communication without first confirming how the computer is presenting itself. When a technician reads the results of IP protocol configuration, the goal is not to memorize every field like a script. The goal is to understand what those fields mean in simple support terms. The IP address shows how the computer identifies itself on the network. The subnet information helps define what counts as local and what counts as farther away. The default gateway shows the usual path out of the local network toward other networks. You may also see whether the system is using Dynamic Host Configuration Protocol, DHCP, which means it received its network settings automatically, and which domain name system, DNS, servers it plans to ask when it needs to turn names into addresses. For a beginner, this is a major checkpoint. If the computer has no useful address, a strange address, or missing network details, that already tells you a lot before you ever test a website, a file share, or a remote system. Once the local addressing looks reasonable, one of the most useful next tools is ping. Ping is valuable because it answers a very basic question that sits at the center of most network problems. Can this computer send a small test across the network path and get a reply back? That sounds simple, but it tells you a great deal. If the machine cannot even reach a nearby network device, the problem is very different from a case where the machine can reach nearby devices but not a distant service on the internet. Beginners often treat all reachability problems as one kind of failure, but ping helps separate them. It gives you a quick way to test whether communication is possible between this system and a destination. That makes it one of the clearest tools for moving from general user complaints into real evidence about what part of the path is still working. The real skill with ping is not just running it. The real skill is understanding what the result suggests. If the computer can successfully reach its own local gateway, that usually tells you the network connection is alive at least at the local level. If it can reach a distant address by number, but not by name, that points in a different direction and makes name resolution more suspicious than general connectivity. If it cannot reach anything beyond itself, then the problem may be much closer to the machine than the user first believed. This is why technicians often work outward in stages rather than jumping straight to a faraway destination. A user may say a website is down, but a better starting point is to ask whether the local path is healthy first. Ping supports that kind of thinking because it lets you test reachability in a simple order from near to far, instead of guessing at the biggest possible cause first. Name resolution is another area where beginners often get confused, because users usually think in names while networks often move traffic by address. People remember names of websites, servers, and devices much more easily than long numeric addresses. That is where DNS matters, because it helps turn human-friendly names into the addresses computers use for communication. A command like nslookup is useful because it helps you test that name-to-address process directly. If a user says a site or server cannot be reached, nslookup can help answer whether the name itself is resolving properly. That is a very important difference. A device may be fully connected to the network and still fail to reach something if the name cannot be resolved correctly. Without checking that piece, a technician might waste time on cables, adapters, and routers when the real issue is that the system does not know where the named destination actually lives. This matters because many complaints that sound like internet failures are really naming failures. A user may say nothing online works, but when you test carefully, the problem may be that the computer can reach destinations by address while failing only when a name must be translated. That changes the whole direction of troubleshooting. Instead of blaming the physical network, you start asking what DNS server the machine is using, whether that server is reachable, and whether the requested name is returning sensible information. This lookup is helpful here because it brings that question into the open instead of leaving it hidden behind a browser error or a vague application message. For a beginner, this is one of the clearest lessons in networking. The path can be healthy while the naming step is broken. And if you do not separate those two ideas, you can spend a long time fixing the wrong thing while the actual issue stays right where it started. When the question is not only whether a destination is reachable, but how traffic is getting there, Tracert becomes very useful. Tracert helps show the route traffic appears to take as it moves through different points between the local machine and a destination. This matters because a problem may not be at the starting point or the ending point. It may be somewhere along the path. A user may say a remote service is slow or unreachable, but the real trouble could be happening several network steps away from the local computer. Tracert helps make that more visible. It is not a magic map of the entire internet, and beginners should not expect every hop to explain itself neatly, but it does help reveal whether the path moves cleanly at first and where it may begin to fail or delay. That can save a technician from blaming the local machine when the trouble is farther away. Thinking about routes also helps beginners understand that network traffic does not simply jump from one computer to another in one motion. It follows decisions about where to go next, and Windows keeps route information that helps decide that path. Most of the time, technicians do not need to treat the routing table like a mystery. They just need to understand that the system has a plan for how to send traffic toward local and remote destinations. When that plan is wrong or unclear, communication may behave strangely even if the network card itself seems fine. Another helpful local discovery tool is ARP, which shows how the machine keeps track of nearby address relationships on the local network. For a beginner, the simple lesson is this. Some tools tell you whether the machine can communicate, while others help explain how the machine is deciding where to send traffic and which nearby device it believes it should talk to. That is valuable when local reachability problems do not make sense at first glance. Netstat answers another very important kind of question. What connections are active right now, and what network activity is the system currently involved in? This is useful because not every network issue is about reaching a website or a server from the outside. Sometimes the question is whether the local machine is already connected somewhere, whether a service is waiting for network traffic, or whether a program is creating many connections that help explain suspicious or heavy network behavior. Netstat can reveal active sessions and listening states, which makes it helpful when you need to understand whether communication is happening at all and what kind of network behavior the computer is showing internally. If you are troubleshooting a local service, an application problem, or unexpected traffic, Netstat helps move the conversation away from vague suspicion and toward visible activity that the technician can reason about more clearly. This becomes especially helpful in remote reachability problems, because a remote issue is often described in a very broad and unhelpful way. A user may say they cannot reach a server, cannot use a remote tool, or cannot connect to a shared resource. That could mean many different things. The computer may not have good local addressing. The destination name may not resolve. The remote path may fail somewhere in between. The destination may be reachable at a basic level, but the specific service the user needs may not be responding. This is why command line tools work so well together. Hostname and IP protocol configuration help confirm who the local machine is and what network information it has. Ping helps test basic reachability. This lookup helps test names. Tracert helps examine the path. Netstat helps reveal current communication behavior. When you use them together, remote reachability becomes much less mysterious and much easier to break into smaller, manageable questions. Imagine a simple support call from a beginner point of view. A user says the Office file server is down because they cannot open a shared folder. A rushed technician might immediately assume the server failed, but a better technician begins by checking the local machine first. Does the computer have a normal IP address? Does it have a gateway? Can it reach that gateway? Can it reach the server by address? Does the server name resolve the way it should? Does the path seem to fail locally or somewhere farther away? Is the workstation already showing active network behavior that suggests the connection is being attempted? None of those questions require wild guessing. They require simple command line checks that confirm one fact at a time. That is how good troubleshooting protects time. Instead of escalating too early or blaming the wrong device, the technician builds a short chain of evidence and then acts on what the system is actually showing. There are also a few beginner mistakes worth avoiding here. One common mistake is treating one failed ping as final proof that a destination is dead. A failed reply means something important, but it does not always tell the whole story by itself. Another mistake is assuming that if a website name does not open, the internet must be down, when the real problem may be with DNS or with the application handling that name. A third mistake is skipping the local checks and jumping straight to distant ones, because that often leads technicians to blame remote systems before confirming the local computer even has working network information. The command line helps most when it is used in a COM sequence. Start with the local machine, then move to nearby network reachability, then to naming, then to the route, and then to the remote side. That order keeps simple problems from turning into complicated stories in your head. By the end of this episode, the main idea should feel straightforward. Windows command line networking tools are not there to impress people with technical words. They are there to answer plain support questions quickly and clearly. Hostname and IP protocol configuration help you understand the local system's identity and addressing. Ping helps test basic reachability. This lookup helps test whether names are being translated correctly. Tracert helps show the path toward a destination. Route and ARP help explain local path decisions and nearby address relationships. Netstat helps reveal active communication and listening behavior. When beginners learn to use these tools as a simple way to confirm what is working before assuming what is broken, they troubleshoot faster, make fewer wrong guesses, and become much more confident with network problems that once seemed too large to understand.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.